Okay, hello everyone. My name is Howdy. I'm from Queen's University. I'm currently a postdoc in sales and business. And today I'm going to give a talk about our recent work, software engineering and foundation models. Yeah.
The slides are not projecting on the...
Oh, maybe share. Okay, yes. Thank you. Yeah, thank you so much. Go to this slide. Okay. Is it working? Okay, yeah. Today I'm going to give a talk about our recent work, software engineering and foundation models, insights from industry blog using a jury of foundation models. So this work was made possible with the support of my collaborators, Kopel and Ahmed. So why study foundation models and software engineering? Okay, we are here because we are interested in this direction. So FM and SE. FMs are transforming software engineering by automating various SE tasks and workflows. For example, code generation, code assistant, vulnerability detection, etc. On the other hand, software engineering practice are being adapted to support the development and deployment of FMwares, which include FM itself and FM-based software systems. So we can see tasks like model serving, scaling, workflow orchestration, data management, etc. And while academic research is growing and have a lot of interest in these two directions, we see that industry perspective have been missing in industry, in our literatures. And where can we get or hear the voices? We notice that technical companies, they often publish blog posts to establish leadership in innovation. So we notice that AWS blog, NVIDIA technical blog, and Microsoft developer blogs. So these blog posts, they offer real-world insights, practical use cases, and reflecting the fast-moving trends. So to conduct our study, we collected blog posts from leading companies and employees in the FM Jury to label them. The first step is collect the blog sites. So we collect a list of companies from NASDAQ and Forbes Global 2000 listing. We curate a list of 17 companies and 35 blog sites from them. And this list can be extended. And we leverage Google Search API to automating the search, searching for keywords like software, large language model, generative AI, and foundation models. We apply filters to filter out unrelated, unrelevant blog posts. For example, author index or index pages. And in total, we collected 4.4 blog posts. And the last step is labeling this blog post. We leverage our FM jury to label them, and we identified 155 FM for SE blog posts and 997 SE for FM blog posts. So what exactly is FM jury? This methodology is used to label documents, and we pass the documents to a panel of foundation models instead of using a single foundation model. So each of them provide labels and corresponding confidence scores. We can merge them to get the final labels. And of course, we can enhance them by asking the model to provide new labels if the predefined one does not fit the content. So by doing that, we can avoid cornering the model to hallucinate about, okay, I can force them to one label, but instead of doing that, we ask them, okay, actually you can provide a new one without hallucination. So after that, we introduce human in the loop. If the label is pre-existing, and we can decide whether to accept or reject it. So by using this methodology, actually we can migrate model bias and enhance accuracy. We can also reduce human effort, and we provide a scalable approach for serving fast-moving fields. So leveraging FM jury for labeling SE for FM area, which includes FM for SE, SE for FM, and unrelated. And we also use it to label FM for SE activities, for example, software development, quality assurance, maintenance. And we also use it to label SE for FM activities, such as model deployment, system architecture, data management, etc. So we choose 3 models, Gemini 1.5 Flash, GPT-4o Mini, and Qwen2 72 billion instruct. So because they are more cheap than the SOTA model. And LLM Jury achieved excellent agreement with human labels across all 3 tasks. So in FM for SE blog post, software development tasks are the most frequently discussed. So the most popular one is code generation, which is reported by all the studied companies. And following that, the second popular activity is software quality assurance. And we also see the most popular task is vulnerability detection. These 2 directions are all closely aligned with our research interest. We also see them reported in survey papers. And we also found that limited focus on software management, requirements engineering, and software design. So this leads to our first research direction. Actually, we can investigate real-world validation of FMs in these 3 directions, given that foundation models are so good at natural language and programming languages. So actually, we could apply them for these 3 domains. And we also noticed that code assistants, they provide multiple functionality supported beyond just simple code generation. We see that they are being used for idea generation, for coding, for debugging, for code review, for configuring the project. And also, you can chat with the assistant. So this leads to our research direction 2. We can evaluate code assistants in software development workflows beyond code generation. So this also aligns with Alma's vision about AI teammates. And software maintenance tasks focus on legacy system refactoring and modernization. FMs are widely used to refactor, translate, and transfer the entire system. For example, we see they migrating Java 8 to Java 17. They migrate application to cloud. They migrate legacy COBOL language to modern language like Java. So let me ask a question. How many do you enjoy writing code? Could you raise your hand? OK, nice. So how many do you enjoy migrating legacy system or refactoring others' code? OK, nice. So this leads to our third research direction. Actually, we can leverage FM for legacy system modernization, translation, transformation, or refactoring. So this like Danny previously mentioned, they already have a lot of work in this direction. And practitioners discussed SE for FMware much more often than FM for SE. As we noticed, 997 SE for FM blog post versus 155. So this leads to our fourth research direction. We should expand research on this domain, especially as FMs support modality beyond just text. For example, image, audio, videos. So in FM for SE blog post, model deployment and operation is the most frequently discussed. Cloud deployment dominates because the resource-intensive nature of FMs. And model serving and scaling techniques are widely adopted. For example, speculative decoding leverage small models to create a draft to speed up the inference. And workload balance, automatic scaling are employed here. We also observed model compression. They help to reduce resource consumption. For example, model pruning, model containerization, distillation. And the growing interest in local deployment also observed for mobile, edge, and PC. This leads to our fifth research direction, performance engineering, for example, load testing and latency optimization for FMware. For system architecture and orchestration tasks, this has become a very popular topic in the blog post. So one architecture is model and prompt chaining. So you provide the input to the model from the first model and prompt, and then pass the output to the second one, and then the third one. You're chaining them together. So the key here is about you break a task into smaller steps. And the second architecture we observed is workflow orchestration, which is more complex. For example, you can use the model to process the first step of the input, and then you apply an if condition here to decide which tool can be used to process the request. And then you can use another model to post-process the results and then generate a response to the user. So this enables a programmatic task coordination. And we also see companies are building AI agents. They leverage FM as a brand and a supply of at least the tools. And it also have components like memory, knowledge, etc. So the key about AI agents is their ability to autonomously observing, reasoning, and taking actions. This leads to our 6th research direction, supporting FM training, workflow orchestration, and AI agents via software engineering activities. For example, we can study design patterns, best practices for these 3 different things. And in FM era, data management has evolved to support both structured data and unstructured data. For example, we see table, text, image, audio. They can all be processed by embedding model and generate an embedding vector to represent them. We call the embedding as feature engineering, which we did not observe before FMs. And to support these embedding vectors, specialized datasets, they are designed for storing and retrieving these embeddings. VectorDB is optimized for storing and retrieving embedding vectors efficiently. And they provide advanced features such as modality search, where users can search image or audio using text queries. And also enable a retrieval augmented generation, which combined the FM with data retrieved from the dataset. So this leads to our 7th research direction, investigating how these evolving data management strategies affect the development lifecycle of FMwares. And model customization relies heavily on fine-tuning methods. So we have an original FM, and then we can fine-tune on domain-specific dataset to create our specialized FM. We can fine-tune with LoRa to make it more efficiently. So by using LoRa adapters, we only fine-tune the parameters in the small proportion and then freeze the weight in the original FM. We also see companies using FM with IRHF to fine-tune the model to make it align with human preference. So this brings us our final research direction, investigating the impact of the shift from training models from scratch to fine-tuning on software engineering activities, particularly in asset management, because here we can see LoRa adapter is a new kind of asset, which is very important in our software systems. So in this presentation, I first discussed our approach for serving great literature, and I discussed about the FM for SE findings and 3 possible research directions. Finally, I presented the findings we get from SE for FM blog post and presented the 5 research directions. So if you're interested, you can check out our full paper. And if you want to discuss more, you can contact me, and I'd love to continue the conversation. Yeah. Thank you.
Great talk, Hao. Anyone has any questions? If not, I have a quick question.
Yeah.
So why this tool is only for grade literature? Why can it not do like academic literature reviews?
I think it's doable. Yeah, but because it's a lightweight method for now. So for fast-moving field, it can provide quite accuracy things, and then we can refresh them. But for academia, we might ask for more systematic way. I mean, you want a more strict definition about the labels. If we have a very well predefined labels for example, for papers, and I think it's very doable.
And I know some of the experiences that you went through with the tool, right? So do you want to just quickly give some ideas about how difficult prompt engineering was for this?
Yes. So because there are 3 labeling tasks here, for each of them, I iterated around 22 versions to get the final results. So that's the difficulty about prompting, hacking, or yeah.
So very nice tool and talk. So I have a question. Let's say, because this field has been evolving quite rapidly, right?
Yes.
So how easy can we refresh, let's say, and see what has been added or what's new? Let's say 3 months later, or half a year later, and so on. Like, how can this thing be easily kind of done to achieve that?
Yeah. We share all the code online. It's very easy to rerun. Like you can just extend a list of companies or company blog posts, and they can automatically run to process the new result. But it costs you money to run it.
But how do you distinguish the like avoid downloading the old one and have running the jury? That was my question.
Oh, actually, we have stored in a data set. So actually, you can base on, we share the data set. So for example, if you want to add new data, you can just check whether the data is existed in the data set,
Okay.
and just by adding the new ones, yeah.
Very interesting work. I'm just curious how powerful your jury is. The reason I'm saying that is I found that some archive preprint, they can claim something to say another paper say that, but when I go to the other paper didn't say that, right? So I think it's not happening 1 or 2 papers. I don't know what's the percentage, but I assume that the preprint is basically you just do it. And nobody's going to argue with you. So I think it's a very, very nice strategy that you do this work with industry articles, because I think those are very high quality. So I'm wondering, like, as you get more data, maybe like, is that like, do you feel when you are doing this jury system, maybe some of the judges find it easier to work, and some others it's really like inconsistency or some observations?
Yes, I can go back to the performance page. So as you can see in this slide, yes. So you can see like the performance between different models are quite different. So our goal here is like we try to tune a model at least reach excellent agreement with human labels. And then other models, they can be just comprehensive or provide different aspects here, and they can cooperate together to provide a final label. That's how we design it to migrate the bias, the model bias. Yeah. Does it answer your question? Yeah.
I think we have to end here, so let's thank Hao.
Okay, thank you.